Assalamu alaikum. Welcome to my channel Tech Talk with Shahid. Our today's topic is development length. What is development length? How to calculate and where to provide this. Development length is the length which we insert in another element to make the good bond. For example, this is our beam. This is our beam and it's our column, and this is the reinforcement which we provide for beam. And if we keep this reinforcement up to the face of column, then this is the wrong way and this is the weakest point, and it can fall anytime when there will be load on this beam. So to make the good bond between beam and column, we need to embed this beam reinforcement inside the column. So this is called development length. So its development length will start from face of column till to the end. So this will be its full development length. How to calculate this development length? Either if you are using IS 456, then there will be different formula. If you are using ACI code, then there are different formulas to calculate. If we will talk about IS 456 about clause 26.2.1.1, its formula is LD is equal to phi, it's a dia Fy over 4 TBD. इसमें जो ये फैक्टर है it's dia of bar, it's Fy is yield strength of reinforcement, which is 415 Newton per millimeter square NMPa, and TBD is equal to bond stress. इस फार्मूला में देर इज वन टेबल 26.2.1.1 जिधर से आपको बॉन्ड स्ट्रेस की वैल्यू मिलेगी डिपेंडिंग ऑन योर ग्रेड ऑफ कंक्रीट एंड डाया ऑफ बार. सो इफ यू आर यूजिंग plain, then you can simply use value from this table. But if you are using deformed bar, जो कि mostly आजकल हर project में deformed bar use की जाती है, then you need to multiply these values whatever we are getting from this table, multiply by 60%. So you can increase its value by 60% when you are using deformed bars. When you are using ACI code, then there will be different formulas which we are using to calculate the development length. Then you need to go for clause number 2.12.2.2 chapter. It's a chapter 12. So there are different formulas which you can use for development length, like LD is equal to 12 by 25. It's Fy under root Fc dash, and then there is again one more formula depending on your grade, bar spacing and other factors. Fc dash Fy, here there will be dB. In this formula, it's reinforcement strength, it's concrete strength, and dB is dia of bar. It depends on which dia you are using, then you can calculate according to this. If you don't have any time to calculate by these formulas, then simply there is a thumb rule. You can consider 50D for development length. D is dia of bar. For example, if you are using 12 mm bar, then simply you can calculate 50 by 12 is equal to 600 mm. So it means if this bar is 12 mm, then from here to here you need 600 mm length to achieve the development length. अब हम इसमें देखते हैं कि किधर किधर हम ये लेंथ प्रोवाइड करते हैं. अभी हमने जैसे एक तो ये डिस्कस किया कि जब हम आरसी बीम का कनेक्शन करते हैं और आरसी कॉलम के साथ, उस टाइम ये हमारी लेंथ प्रोवाइड करते हैं रीइंफोर्समेंट की टू अचीव द गुड बॉन्ड. सेम एग्जांपल व्हेन वी हैव अ कॉलम कनेक्शन विद footing, this is our footing, so it's a reinforcement. We embed inside the footing. That also one example of development length. इसकी development length जो है इसकी footing के फेस से लेके इस bend के end तक, तो ये इसकी development length है which we provide to make a good bond between RC column and RC footing. Same way when we are connecting our slab with RC column, then also this way slab reinforcement we insert inside the column to make a good bond. So hopefully कि ये चीजें आपको clear होंगे. If you learn anything from our this lecture, then please subscribe my channel, like it, share it and comment it. If you need any question related to this, please send your comment and we will try to reply as soon as possible. Thank you so much.